chapter 3. In section 3.1, we're going to study linear inequalities and absolute value, which is essentially algebra, and we may sprinkle in a little bit of pre-calculus, like the actual meaning of some absolute value inequalities. So with that, today's objective will be to solve and graph linear inequalities in one variable. So let's start by solving. All right, so here's a typical linear inequality. Note it's linear because the highest degree term is first degree, and it's an inequality because we have that inequality symbol less than or equal to. So algebra 1 right now, let's solve for x. So the first thing I would do is subtract x from both sides to get my x's on the same side. So 3x minus x would be a 2x, and then minus 4 still there is less than or equal to 10. And now let's add 4 to both sides. So we have 2x is less than or equal to 14. And then let's divide by 2 to get an x is less than or equal to 14 divided by 2, which is 7. So that's how we solve an inequality. Simple enough. Let's graph. So keep your graph simple, all right? Just draw a simple number line. And you don't need all these fancy hash marks like I have on my PowerPoint. Right now, x is less than or equal to 7. The key number here is a 7. So one hash mark with a 7 underneath it, and you think less than or equal to. What kind of dot are you going to put on that 7? Because of the equal, we'll go solid dot. And x is less than or equal to that 7. So less than, which way is my arrow going to go? That's right, to the left. And there's your graph right there. Let's practice one more. So 8 minus 2x divided by 5 is greater than 6. So first thing we would do is get rid of this divisor. So let's multiply both sides by 5. So 8 minus 2x is greater than 5 times 6, 30. Now, a couple routes you could go, but I want to keep this a negative to make a very important point. So I am going to subtract 8 from both sides to give us negative 2x is greater than 22. Now, I'm going to divide both sides by negative 2, but when I multiply or divide an inequality by a negative 2, remember we need to reverse the orientation of the inequality symbol or flip it in layman's terms. So negative 2x divided by negative 2 is x, and x is now less than 22 divided by negative 2, which would be negative 11. And let's graph that one. Key number on my number line will be negative 11. And look at your inequality. I don't see an equal, so I need an open dot on the negative 11. And less than tells me, once again, my arrow will be going towards the left. Solve and graph inequalities. I bet you want a whole bunch of those on a test, don't you? All right, so let's practice graphing some double inequalities. First, let's say it correctly. Okay, let's graph it first, I guess. Okay, so my key numbers are negative 3 and positive 4. So negative 3, and since I have hash marks, I better count these. Negative 2, negative 1, 0, 1, 2, 3, 4. There's my 4 right there. Oh, and by the way, notice that I put the open dot on negative 3 because there's no equal sign. And now look, there's an equal sign here with the 4, so I better put a solid dot right there. Excuse me. Now, negative 3 is less than x, and x is less than or equal to 4. Do you agree? That would be every number in this interval right here, including 4, but we have to be greater than that negative 3, and that's why this is open. All right, now let's do this one. 6 is less than x, and x is less than 1. Let's say that one more time. 6 is less than x, and x is less than 1. Now the key is this and right here that I have in red. All right. 6 is less than x, and x is less than 1. Does that make any sense? Because, you know, there's x right here and 6 is smaller than it, how can 6 be smaller than x if x is less than 1? Yeah, that's not possible, right? So here's your pre-calculus sprinkled in right here. There is a solution to this inequality, all right? And by the way, if you ever write a double inequality like this that does not make any sense, all right, you're probably going to lose a few points, all right? So anyway, if you were given an inequality like this, you would be like this monkey right here going, that makes no sense. So I'm going to say x is the empty set. There are no solutions because that inequality makes no sense. There is no number where 6 is less than the number and the number is less than 1. Empty set. Okay, now everybody draw this chart in your notebook and let's try to fill it out. All right, what does absolute value truly mean? The absolute value, like the absolute value of x equals c. Well, absolute value means a distance to 0 right here. Okay, so now think about this a second. Distance, all right? What's the meaning of the absolute value of x equals c? I mean, that's the way we typically say this. But what this means is the distance from x to 0 equals c units. So the distance from x to 0 is exactly c units. Okay, now what's this graph look like then? Draw a simple graph. The key number is this will be centered at 0 because we're talking about the distance from x to 0. And if the distance from x to 0 is exactly c units, that means I could be c units to the left of 0 or c units to the right of 0. So that would give me a negative c or a positive c. And because of the equals, I'm going to put a solid dot on each of those hash marks. So what is my solution right here? X equals negative c or x equals positive c. Now, the absolute value of x is less than c. This truly means the distance from x to 0 is, and now less than c units. So let's go to the graph. Centered at 0 again, and you've got your negative c on the left and your c on the right. Now think about this. The distance from x to 0 is less than c units. So I'm going to put open dots on negative c and c because the distance from 0 is less than that c units, and then we're talking everything in between. There's my perfect graph right there. So the solution is, and whenever we have a less than, we're going to have an and here. So we're going to start with negative c is less than x, and x is less than c, our double inequality right there. Okay, so it will be your job to go from this absolute value inequality to this double inequality, which people can tend to see a little more clearly. Now, how about this one? The distance from x to 0 is greater than c. So the distance from x to 0 is greater than c units. So same graph, and we're going to go the opposite of c on the left and c on the right. And now we are greater than, so it's still open dots. But greater than means, okay, I'm working out. Arrow this way and arrow that way. And then my solution, there's going to be an or here because this is two separate inequalities on the same number line. X can be less than negative c, or x can be greater than positive c. And there you go. Now, let's add a little bit to this. So the same chart, but now I have a -5, a -1, or a +3 within the absolute value. Now, what does this mean? Well, remember when it was just the absolute value of x and we said the distance from x to 0? Well, if I have the absolute value of x -5, that means the distance from x to 5. The distance from x to 5 is exactly equals 3 units. So now instead of being centered at 0 on my graph, I'm going to center my graph at 5. And then I think to myself, what number is 3 units to the left of that 5? That would be a 2. And the number 3 units to the right would be this 8. Exactly equals means I have solid dots. So my solution is x equals 2 or x equals 8. Now the inequality. The distance from x to 1 is less than 2 units. All right, so now my number line will be centered at 1. And I am less than 2 units from the 1, so what number is 2 units to the left? That would be -1. What number is 2 units to the right? That would be +3. Okay, now solid or open dots. Less than, no equals, open dots. And the distance from x to 1 is less than 2 units. That would be everything in the interval between those two open dots. So this is an and right here. So this is -1 is less than x, and x is less than 3. And we write that as a double inequality. One more. Uh-oh, there's a plus. What am I going to do? Isn't +3 the same as -3? Oh, look at that. So this means the distance from x to -3 is greater than 2 units. So now my number line will be centered at 2. Excuse me, -3, all right? And I am greater than 2 units to the left and 2 units to the right. So that'd be a -5 and a -1. And now greater than, no equal sign, so open dots. Okay, and greater than, that means I'm not inside, I'm not within this interval. I'm going to the left forever and to the right forever. So this is an or statement right here. So I see by that graph that x is less than -5 or x is greater than -1. All right, cool stuff. Okay, so now let's do the algebraic method, and this is how you were taught to solve absolute value inequalities in algebra. We're going to start with a sentence or an absolute value equation or inequality, and then we're going to write the equivalent sentence or the first step we would use to solve. So our first sentence will be the absolute value of ax plus b is c. So think about that, that means that this ax plus b might equal the opposite of c because the absolute value of the opposite of c is c. So this creates two sentences over here on the right. I could say that ax plus b equals the opposite of c, or I could say ax plus b equals c. So I just wrote that ax plus b equals plus or minus c. And then you'd have to solve both of those. Now let's go to the inequality. The absolute value of ax plus b is less than c. So, all right, less than, that's going to be one of those and statements again, which means we can write a double inequality. And that means that the opposite of c could equal this ax plus b, or I should say the opposite of c is less than ax plus b, and ax plus b is less than the c. And then you solve this inequality right there. Okay, now one more. Let's go greater than. All right, now this one, when you have a greater than after your absolute value, that's an or situation. So that's going to be two separate inequalities. It's still considered compound because of the or. So this is going to be, well, now let's think about this. So ax plus b could be less than the opposite of c, or ax plus b could be greater than c. All right, and there you go. That's how you did that years ago in algebra right there. And we will still do this here and there. Okay, so Let's use the algebraic method to solve the absolute value inequality. The absolute value of 3x minus 9 is greater than 4. So we're going to do this just the way you did it in Algebra 1. All right. Let's see if we can do it without that chart. Greater than. Okay, that means I'm going to have an OR situation right here. And that means my graph is going to be working out towards negative infinity on one side and infinity on the other. Something like that right there. So let's set this up algebraically. Now, doesn't this imply that whatever is within the absolute value, 3x minus 9, it could be less than the negative 4, or 3x minus 9 could be greater than the positive 4. Now let's check that with our little cheat sheet from algebra. So we just did this one right here. The absolute value of ax plus b is greater than c implies ax plus b would be less than the opposite of c, or ax plus b could be greater than c. And we've just done this right here. Now let's solve each of these separately. So let's add 9 to both sides. So we have 3x is less than negative 4 plus 9. That's a 5. Divide both sides by 3 to get x is less than 5/3. Now over here on the other side, let's add the 9 again. So we have 3x is greater than 4 plus 9, 13. And then divide by 3 again. So x is greater than 13 over 3. Now these are two separate inequalities with an OR in between them right there, which is still considered a compound inequality. It's just we're working out like this. And we could graph it too. We have two key numbers on this graph, 5/3 and 13/3. And I better count these out with the hash marks. 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, 12/3, 13/3. How did I do? There we go. And notice I did open dots because there's no equals. Open dot on each of those. And if x is less than 5/3, that's why this arrow will go to the left. Or x is greater than 13/3, this arrow will work to the right. Just like we have above right there. Okay. Think we might be able to do this geometrically. All right, this is the same problem, but this time we're going to solve this absolute value inequality using the geometric method. And it is my goal that you guys go away from the algebraic method and really see this geometrically. That gives you real true understanding. So with the geometric method, within the absolute value, I'm looking for an x minus a number. I don't want this coefficient of 3, so I think to myself, can I factor a 3 out? Yeah, we're not going to use you. We're going geometrically. So let's take a peek here now. Well, 3x and negative 9, the common factor would be a 3, and 3 times x is 3x. And 3 times negative 3 is negative 9. Now we're still solving for the x, so let's divide both sides by positive 3. So that's going to give me the distance from x to 3. Did you notice how I said that? Is greater than 4/3. So now I can go right to my graph. Okay, and I'm going to have an inequality graph that is centered at x minus 3, I'm centered at 3, and I need to work 4/3 units to the left of 3 and 4/3 units to the right of 3. So this distance is going to be negative 4/3, and this distance will be positive 4/3. Now, before I do the arithmetic, let's think about our dots. Greater than. There's no equal sign, so open dots. All right. And greater than gives me an OR statement, so my arrows are going to work out towards negative infinity, and then on this side towards infinity. Now, all I need is the arithmetic. 3 minus 4/3. Well, how about we go 9/3 minus 4/3 would be 5/3. And then 9/3 plus 4/3 would be 13/3. And there's the perfect graph. Okay, this is x is less than 5/3 or x is greater than 13/3. Oh, look at that. X is less than 5/3 or x is greater than 13/3. Beautiful. Okay, let's take a look at another absolute value inequality, and let's do this one again. First time we'll do it with the algebraic method. All right, and let's see if we can do it without our little cheat sheet down here. So if the absolute value of 2x plus 5 is less than or equal to 7, that means I'm going to have an and statement. Less than or equal to, less than means and that means my graph is going to be an interval within 2 points. Something like that right there. And also solid dots because of the equals. All right, so let's set it up. All right, well, on the left, see the 7? That's my c. So I'm going to have the opposite of c, or -7, is less than or equal to whatever is within the absolute value, 2x plus 5. And 2x plus 5, did you notice the and there, is less than or equal to positive c, or in this case 7. Now we simply solve the double inequality. We're solving for x. So if I'm going to solve for x, I'm going to have to subtract 5. But I have to subtract 5 from all 3 sides. Oh, by the way, let's double check this. Less than, right here, absolute value of ax plus b is less than c, implies negative c would be less than ax plus b, and that is less than c. And that's what we have right there. So now let's go ahead and subtract our 5 from all 3 sides. -7 minus 5 more, -12. 2x plus 5 minus 5, 2x. And 7 minus 5, 2. Now, solve for x, we have to divide all 3 sides by 2. So -12 divided by 2 would be -6. 2x divided by 2 would be x. And 2 divided by 2 is 1. So -6 is less than or equal to x, and x is less than or equal to 1. Now let's graph that. So I'm going to have a -6 with equal sign, solid dot. Okay. And then my other dot will be a 1. Since this, I do have hash marks, I better count -5, -4, -3, -2, -1, 0, and 1. I'm going to put a solid dot right there for that 1. Okay. And since x is within this interval, I'm going to do a solid line between the -6 and the 1. And there's my graph. Do you think we could do this one geometrically? Ooh, I don't see an x minus a number, but I bet you we can take care of that. Okay, let's attempt the same absolute value inequality geometrically, which means we don't need a chart from algebra. So my first thought is, I don't see x minus a number, and I know I need to get rid of this coefficient of 2. So let's factor a 2 out. So 2 times what is 2x? That's an x. And then 2 times what would give me a positive 5? That would be plus 5 halves. All right. How about now? Let's divide both sides by 2 to get the absolute value of x plus 5 halves is less than or equal to 7 over 2. Now, I need an x minus a number, and I see x plus a number. So can I rewrite this like x plus 5 halves? Isn't that x minus -5 halves? And there's my inequality. Remember how we say this now. The distance from x to -5 halves is less than or equal to 7 halves. So we go right to the graph, and this will be centered at -5 over 2. And then I'm going to need a number to the left of -5 over 2 that is 7 halves away, and a number to the right of -5 over 2 that is 7 halves to the right. Now those two numbers, because of the equals, those are going to be solid dots. and less than or equal to. This is an and statement, right? So that means we're everything in between those two dots. Oh, beautiful. Now, what value is this dot and this dot? Negative 5 halves minus 7 halves would be negative 12 over 2, which I'm going to write as a negative 6. And negative 5 over 2 plus 7 over 2 would be 2 over 2, which I'm going to write as a 1. So there's my perfect graph right there. And now let's go ahead and write the double inequality. So negative 6 is less than or equal to x, and x is less than or equal to positive 1. So that's absolute value inequalities, and I would like you to practice with these problems right here. You all have a wonderful day.